Okay, hi everyone. Well, this is I'll try to make a quick presentation talking about a specific implementation of some of the practice that we need to take into account in the DevOps process. As Daniel mentioned, many of the things related to DevOps are mainly a cultural change. So we are talking about this a little bit, but then we will review a sample scenario where you can put some quality process in place in a pipeline to accomplish the quality assurance of the microservices, and then some small outcomes of that experience and some best practice to share that eventually we can share lately in a more deeply conversation. So let me introduce myself. Well, I'm Javier Re. Yeah, that Re is my surname. It's very short. I have some stories about that from my childhood when I was young. So not matter right now. Husband and father of two kids. Very proud. I'm a software engineer and master of business administration. A bass player. I say always that it's a continuous learning because I'm still learning. It's difficult for me, but I don't give up to that. I have more than 20 years on technology experience and very fan of the quality assurance, agile and DevOps methodologies, and CEO of Crowdar, where we implement some of these practices that we will share. So basically, uh, what is about DevOps? There's many conversation about this, and I try to be concise on this. Basically, DevOps is a cultural change, a cultural shift to move to a more collaborated environment where we try to eliminate the silos between different teams, which is usually a big problem. So the most important thing, since my perspective, and probably many of the speakers in this event, is that the cultural change to eliminate silos between the different specialities and the different skills in the teams is the most important thing. But at the same time, DevOps is impossible without automation and without integration of specific tools and software that makes it possible to deliver software small and quickly. So is the purpose of all of this. So basically, uh, as DevOps start as a cultural change and a purpose of eliminate silos between the different areas. At the same time, as I mentioned, we need to automate the integration between these pieces, that the flow of deployments and new code being released many times during the day. Sometimes it has to be a mandate. So in this presentation, we will see how to implement some of the practices with the specific cases in this area, basically starting in the code, in the build, test, release, and deploy section of this diagram. So basically, how we do ensure quality of a microservices. If we talk about microservices architecture, the applications are split in small pieces that are isolated, that are independent, and can run and be deployed as a single piece of software. So it's very important to have that split and have the architecture in place to do that, but also adding the possibility to do deployments automatically with a CI/CD pipeline needs some process in place to make sure the quality of those pieces of software are delivered correctly. So as we deploy software very quickly and with a faster changes, we need to make sure that we don't break anything. So basically, the purpose of this to not just automate the deployment and the build of this piece of software, which is a microservices, but also to run tests on that portion of software in the same process. Otherwise, we will deliver software very quickly, but with lower quality. So it's a critical portion of the pipeline to do functional testing, to do automation testing, and also eventually to do non-functional testing like performance and security check-ins. So in this case, we will just talk about functional automated testing, but it's not less important to have in mind all the other kind of testing. So the execution of those tests must be done each time that the microservices is deployed. So that generates the need of automate a small set of scenarios, just checking that microservices in a specific behavior, and then later on integrating them most in the rest of the deployment. We will see a sample of pipelines later where we can see how to do that. So the other point that is important to define when we try to automate or to keep the quality of microservices is a simple step-by-step approach, is to identify the endpoints that we want to automate the test. So that's the behavior of the microservice that we want to automate and deploy, and also have some feedback, right? So we need to understand that the test automation is a tool to help the developers to have quicker and fast feedback if something is broken. So we need to understand how this change or how the code that the developer just committed affected in a good way, implementing the functionality that is purpose of that change. But not just that, we need to also make sure that the developer doesn't make or don't inject a bug into the code and break something else. So the purpose of this test automation is, as I said, is to provide fast feedback. And the way to do it is, as we will see, to integrate into a pipeline. So basically, here is a very popular picture that I like to show in these presentations, because shows very easily how the automation testing approach has to be implemented to be efficient and to add value to the process of development. So basically, in the traditional approach, or mainly in the cascade approach that we used in the past, there's a few unit tests to check some pieces of the code in a method level or a very low level. Then we have some automation, but in more a kind of regression kind of automation at the end, and then a lot of effort doing UI manual testing. To prevent bugs, which is a specific approach that is initially stated by Martin Fowler in their blog. So we'll have at the end the links to this paper. The idea is to increase the number of tests in the base of the pyramid and decrease the number of tests in the automation piece to the top of the pyramid. Why? Because at the bottom of the pyramid is more efficient and more cheaper to build and to write those tests, and more cheaper to execute that. As soon as we move up to the pyramid, so from the backend or from the code passing through the backend to the UI, the automation is going more and more difficult in two terms, basically into the effort to write those tests and to maintain those tests, but also the time that we spend to execute those tests. So basically, the big base of the pyramid has to be unit test. Then we can make component tests to test the microservices isolated, or in a way that we can test their interface, their behavior, but very, very basic behavior. So let's say we tried an endpoint, and we can check if that endpoint responds with a 200 response code or a 400 response code, and with that would be the test. Then we add more functionality to those tests, and we can test the contract. The contract is the interface that exposes the microservices. So we can write tests to check if the JSON provided by the microservices, either in the input or the output, is correctly formed. If that contract is not working, it doesn't make sense to continue testing the microservices in a functional way, because the contract is broken. So the very basic kind of test that we can write at the very beginning, after the unit test, is to write component test and to write contract test. So on top of that, we can write behavior test in an automation way. So we can test the backend of any application, testing the microservices, but in a functional way, not just testing the response code or the contract, but writing a specific business scenario that has to be executed by the backend. And so in that case, we can write cheaper in effort test using just the backend, and also run those tests very quickly and very often. So with that approach, we can detect or prevent bugs, as this approach states, more easily and with less effort. Think that a UI test automation usually takes 4 times in time of execution than an API test. So it's a matter of trade-off that and taking advantage of those kind of testing. And obviously, exploratory testing is on top of the pyramid and is not optional. So we cannot replace completely the exploratory testing with automation. We need to combine and complement that. So moving forward, what is the approach that we propose, and after many implementations in projects, we think that is the best approach, and it's part of a paper that one of the members of our team write, that will be at the end of the presentation, a link to share that. Is basically a split to start in a sprint, right at the beginning of the sprint, when we need to write a user story, as BAs or product owners write that user story. Immediately after that, we need to start writing acceptance test criteria. Basically, that is a job that the testers and the BA has to do, using the user stories as an input. With that approach, we start from the very beginning of the sprint to write criteria and scenarios that then we will test as soon as we develop the code. So this approach set just at the beginning of the development sprint, as soon as we have all the user priorities written and the backlog prioritized, the developers start picking user stories and using the acceptance criteria to test that user stories before integrate the code. So that is very important, because at this stage, the developers and the testers work together to make sure that the quality of the pieces of software, in this case microservices, are built, fit and match the quality expected, which is the acceptance criteria. Then we can add more tests, but at least in the first approach, which is the sprint, where the code is written, we need to write the test and execute those tests. We cannot wait at the end of the sprint. That is a bad practice. So as soon as the developer starts writing code, the tester starts to write tests and to automate those tests. So look at this, that at the very beginning of the development process, we start doing automation. So this is a big recommendation, because otherwise all the test automation will be at the end and at the sprints, or probably later on the following sprints, and that generates technical debt and generates a problem of the tests don't represent the real code that is underdeveloped. So that approach, so writing the test automation after the sprint that the code is built, is a bad approach, because sometimes generates disassembly between the code and the test. We will see some of the problems that has that approach in the later in the presentation. So as soon as the development is complete during the sprint and the tests are complete, we integrate the code into a feature. So in that integration, devs and testers work together to make sure that that integration of microservices accomplish the purpose of the expected behavior in the user stories. So let's move quickly to make sure that we can share more. So it's not, I mentioned that the only purpose of having automation in place is not just to having a green dashboard with all the tests passed and don't give any value to the process. The only purpose of the automated test in many areas, as I see in the testing pyramid, is to add value and to accelerate the feedback to the developers. So basically, this is a general pipeline where as soon as we commit and merge the code, we build test, very basic test, unit tests, static code analysis. So this is the first stage of quality control into the pipeline. Then we deploy the component, and then we run two specific automated tests. One is a smoke, and a small regression. So this is a traditional pipeline, and at the end we do a UAT. So in the automated test, we do installation and deployment test, integration test, functional test from UI and API, and non-functional test, as I mentioned. And then at the end, we run a UAT. So this is a manual exploratory testing, or demos, that we mentioned in the pyramid as well. So going deeply a little bit, if we look at the commit pipeline, which is a small pipeline that is run every time that a developer commit a piece of software, we do the same basically. But in this case, we just see the portion of the pipeline that is repeatedly executed each time that the developer made a commit. It's not a release pipeline, it's more a commit pipeline. So as soon as we, as a developers, commit code, all these small regression and smoke tests are executed. So we don't need to wait until we have a release candidate to execute automated test. We run automated test every time that we commit code. With this approach, we shorten the period of executing automated tests. The tests are executed more frequently, so we can feedback the development team much faster than on each release. So we accelerate the feedback to the developers, and they can fix expecting code. Sorry for that. What happened when we have a release candidate? So we have a feature branch that will be shipping with a set of changes or new features. We execute the same piece of process that we mentioned in the candidate in the commit pipeline. We run always the unit test, the static code analysis, the low-level integration test. We do the deployment, and we do the automated test, including the installation, integration, functional test, and non-functional test. But then we do the acceptance test, including the manual and exploratory testing, and a full regression in parallel. That regression of test will be an automated test set as well, but is a full regression. So we don't run the full regression in each commit. We run in each release pipeline in release candidate pipeline. So why we do that? Because we've been executing small regressions all the time in each commit, and if we do a regression test all the time in each commit, probably takes longer and doesn't make sense to accelerate the feedback. So finally, we do the UAT with the exploratory testing and demos. So, no, sorry, this slide is a little bit messy. I don't know why. Probably it's a matter of StreamYard. But basically, what I like to show you is a small sample of a real microservices that is built on Node.js and a sample test automation code that tests that microservices, and also a pipeline that includes that test automation to show you how to integrate that into a real pipeline. So for this demo, I will use GitLab.com as a CI/CD and a code repository tool, and also I will use Lipia, which is an open source framework built on Java that lets you write tests in any platform and in any application without depending on writing the same language that the code is developed. So if we look at this picture, just to show quickly how this architecture is built, Lipia has basically a core framework, which is an open source framework you can see later on GitHub eventually, that has many connections. One of the connections is basically integrate with any test management solution. Then they have different supported reports like console reports or extent kind of HTML report, or you can connect to a report provider like report server in Lipia, which is not the case. We will not show that, but it's possible to do that. But also Lipia is able to integrate with web apps, mobile apps, backend, and Windows apps, and also in the backends with databases or APIs. In this case, what I will show is how to write some test in using Cucumber language with Lipia, and using testing REST API, not a database, but it's something that is possible as well. And I will integrate or show how to integrate or how to run this test written from a GitLab pipeline. As you can see, Lipia also is able to integrate with many other pipelines solutions, but in this case, we will show you with GitLab, which is a popular solution nowadays. So let me share my screen. So basically, I will show a little bit of code. I think that is okay. Looking some code. So basically, what we have here is too many projects, right? It's two different projects. One is the backend of the application that I tried. So the microservices that I try to automate. So basically, this is the code of the microservices, which is basically an attachment microservices that let an application to attach files to a specific item in a test management solution. So this microservices has the responsibility of just managing attachment. So no matter what is the item that I'm managing, I want to attach a file to that, and that's all the behavior that I expect. So basically, this is the code. I will not review the code of this Node.js microservices, but I want to share with you the pipeline that we will see. But first, let me show you the test that we written to test that microservices. So for that microservices, what we have here is a test automation project. So if you look at this, we have two different source code projects. One is the microservice itself, which is the Node.js code, and then we have a project, a specific project in the repo based on Lipia, where we rewrite the code to test that microservices. So in this case, we have many features. Obviously, these are all the tests that the application that is under test is performing, but we will just choose the test attachment manager, which is the microservices that I mentioned, which is responsible to attach files to a specific item. So in this case, we have a very simple feature, which is a crude kind of test, which is create attachment, get attachment, and delete attachment. So basically, in these scenarios, what I try to do with this test scenarios is to perform operations using the API, but not using the front end. So we can write with Lipia, which support Cucumber, which is an implementation of or a support for Gherkin language, which is a high-level language that we use to describe behavior and to test with behavior, is to write the specific code, which is very easy to understand by a product owner or a regular tester without knowledge of programming skills. So in these scenarios, we have these three tests, and if you can see, this is a very basic test, which is as soon as I want to create an attachment, I perform the operation with the attachment, the file name that I want to attach, and the parameters. And I expect, so this is the validation of the test, that the status code is a result specifically, in this case, a 201 status code. So in this other test case, we expect a status code of 200. So with this information as an input, we can model the scenario and eventually use different sample tests or sample data to run this test with the same behavior. So that is a very powerful tool that lets you write a single scenario and include many sample test data to execute that. And in this case, I made a little bit more complex scenario compared with the previous one, where when I try to delete an attachment, first I need to obtain the ID of the attachment and then perform the operation of deletion. So that is basically the test that we will show. These scenarios are written in Gherkin, but then those Gherkins are written in code, basically. So what we do is to manage to map these steps, each of the steps, like this, with a piece of code in Java that lets the test automated to interact with the application. So let's move a little bit quickly. I have a sample run it first here, but let me clean my console. So I will run this test, but as this project has many features, as we can see here, we have many features, but I don't want to run all these tests. I just want to run the related to attachment. So I will run with this command, which is a Maven command, just filtering the tags related to attachment. So in this case, I will run from console. So this is the job that a test automation engineer will do during the sprint, as I mentioned in the pipeline. So I will run this test, make sure that it works, and as soon as this works, I can provide feedback to the developers. But if you can see, this is run very quickly, and it lasts 18 seconds to these three different tests. And given this result, I obtain the result of the execution. You can see in green that all the results are okay. So basically, the run throw a result with 3 tests okay and 0 failures and and zero skipped test. So as soon as we run this, we are okay. But what happened here? I'm running this test in my computer, so it's not providing value to the developers. So to do that, we need to integrate into a pipeline. So let's see a pipeline, a real pipeline in GitLab. So basically, what I have here is the code of the attachment manager. So the microservices in this repository is the proper code of the microservices, as we see before, and then here we can add into the pipeline of building this microservice a specific stage. So what we have here, if we can see, is a pipeline that build the solution with different stages. So let's see in Visual Studio Code to make it more easy. So here I'm showing the same pipeline, the YAML file that execute all these steps needed to basically build the code, package the code, deploy, and test. So basically, what we have here is some variables, some specific variables that I add to this pipeline, so that are needed to execute the test that I just showed you in the other project. So here I reference the code, the repository location of the test, and these variables I will be using in the steps. So as soon as the stage are executed, sorry, these packages or these stages of the pipeline are the standard, and it's not detailed here to avoid noise in the presentation. But the testing stage, which is here, is mainly responsible to execute the test that I just written into the other projects. So what I do here is to instance an image of Lipia runner, which is a Docker file that I use to run the test, and I write before running the script. I run this specific clone.
Javier,
Yeah, sorry.
we are running out of time, so please wrap up quickly,
Yeah, I will
please.
try to. Okay, I'll try to do it quickly. I started a little bit later, so I try to move it quickly. So basically, the first step is to clone the code, then run the command that I showed you in my computer, and depending on the branch that I'm merging, I execute a specific tag or a full regression test. So to avoid running this right now, which takes some time, I will just show you the result of this execution using the logs of the GitLab pipelines. So basically, all these are runs of the pipeline that I executed and was executed during each commit of the development team. And if I see the details of this, I can see that the pipeline has many stages, as I can see here, right? Build, backcache, deploy, and testing. So each of them has their own results in the log. And if I see the test results, I can see all the results that are through the console. And at the end of the pipeline, in this case, I run all the full regression tests with 66 scenarios instead of just 3 that I showed you in my computer. And these pipelines are executed successfully. So the build is successfully, and as you can see, the pipeline execution was passed. So in this case, for example, some of the tests failed, so the pipeline was stopped and the deploy was not executed. So this is an important topic to make sure that as soon as we deploy code, we test accordingly with the automation. So going back to my presentation, one last two slides is to explain a little bit that not all is nice in this kind of a scenario. What one of the things that usually happen is that we can have flaky tests. Flaky tests are basically when test fails or pass in the same version of code, so it's not predictable. So basically, we need to prevent those flaky tests to avoid having a false negative feedback to the development team. So common causes of flaky tests are asynchronous wait. So when we execute a microservices that depend on another, probably that microservice is not ready yet, or even in between the UI and the backend, sometimes happens. Concurrency, when we have different microservices acting at the same time or running tests in parallel, that has some problems because of that, or missing data or inconsistent data. Also, internal server errors or resource leaks, when we have a service that is needed to perform a test and that service is not available, and that will be a common causes. These are best practice. I don't want to stop here too much, but basically there are some recommendations to avoid that, which includes basically manage the test data programmatically to make sure that the data is available, collaborate between devs and QA to make sure that the code are aligned, that the services are available, and also add negative scenarios to automated tests to test the specific behavior that are not the common ones. So basically, this is all the learnings and that we obtained from this presentation, and I hope that you obtain from this presentation, that basically automated test helps to ensure the quality of microservices. We make sure that the quality in each release and in each commit by running frequent test automation and having those pipeline in a CI/CD pipeline. Those tests in a CI/CD pipeline is very important. It's not enough to run in a local computer of the developer. We need to integrate into a pipeline to make sure that the results are good. And obviously, this helps to reduce the testing effort, which is sometimes difficult and takes a long time to do a full regression. So this is the reference that I used to prepare this presentation. So anyone that needs or wants to go deep on this can use these resources or contact us eventually. This is my contact information and our website at Crowder, where we provide specifically these kind of services. So I think that this is all that I have. Sahil?
Thank you very, very much, Javier, for the demo and for the nice, insightful, and marvelous talks. So we have got two questions, very quick ones.
Okay.
First one, both are together. So first part one is, what is your recommendation for integration test for a service that has an external API as a dependency?
Okay. Well, in that case, it depends. But if you have an external dependency that you are not sure that is available all the time that you run your test, probably a good approach is to build a mock. Basically, a mock is a double of or a stub of the service that you need to test integrated, and act as a fake service. So if you are not sure that that service is available, building a mock with the same contract of that microservice could help to run those tests and avoid the dependency of having that microservices up and running all the time. So you focus on your test or your specific behavior, but the dependency of that service is not tested in that process. Probably you need to write a specific test to test that service, but If it's not available all the time, and I imagine the question is related to that, you can write a mock. There are
Okay.
many tools to do that. Mhm.
Second question based on the first one. So far, I know about the mock server to provide the HTTP
Mhm.
response to simulate the expected API behavior. Would you suggest another approach?
Um, no, that I think, well, it's what I mentioned is is a good approach to use that. There are many solutions to do that, to do mocks basically. Insomnia is one of them, for example, that is pretty new and very popular now. Um, but there are many. Um, what I suggest that is to write mocks to do that, but also make sure that you write tests to test that the specific service. Don't forget to test that the specific service integrated sometime, because otherwise you trust in a mock, and eventually, if that contract change of the external microservice and you don't test it accordingly, you have an issue in production for sure. So don't forget to test isolated and then integrate as soon as is possible.
Okay. I think that was the end of the question answer. So thank you very much for your time and effort for explaining the nice topics and the demonstrations. So
Okay.
I hope you enjoy the day and the rest of the conference. So thank you very much for your time. Thank you, Javier.
Thank you, Javier. Thank you for inviting me.
Same to you. Bye.